Biomimicry is a way to explore nature's strategies of adaptation. In my project, Cholla cactus, a family of cacti, is used to inspire a set of semi-cylindrical designs that intend to mimic the proven resilience to bending and torsional loads they have in their natural habitats and to incorporate them into engineering applications. My name is Jocelyn Palancares, and I am developing tubular bioinspired metamaterials. The first challenge was to design and synthesize the characteristics of the model. Since cholla cactus have several characteristics that presumably enhance their performance, the first model only included the porosity in a cylinder. The second models included variations in their cross-sectional areas, and the union of these two characteristics are part of the third set of models. The next challenge was to prove which of these characteristics are related to the behavior of the models under torsion and bending. This is done through finite element analysis. In this experimental phase, the objective is to characterize the elastic properties as well as effective torsional stiffness. Parallel to this phase, physical test of the additively manufactured models is performed with the intent to validate the finite element analysis results. Up to this point, the findings are that in fact, the observed characteristics of the biomimetic phase affect the performance of the models. The expected contribution of this research is to develop a guideline for the creation of porous cylinders that can be used into engineering applications.